Hi all, I am Sandra Mariam Simon of M1 SNIT. Today I am going to present to you about the topic sensitivity of Wheatstone bridge and potentiometric circuit. We had already discussed about the potentiometer circuit and Wheatstone bridge. As we all know, these two devices application is to determine strain. So, before going to these devices sensitivity, let's look into what is strain gauge sensitivity. Sensitivity of strain gauge is a fundamental parameter of strain gauge to strain and it is indicated as gauge factor. So, gauge factor is defined as the ratio of fractional change in electrical resistance to fractional change in length or strain. That is, GF is equal to delta R by R divided by epsilon. And for metallic strain gauges, the value of GF is usually around 2. Coming to our topic, first let's discuss about sensitivity of potentiometer circuit. It suggests how much small voltage difference can be measured by the potentiometer. For the same voltage, if we increase the length of the potentiometer resistance, length of resistance per unit voltage also gets increased. Therefore, sensitivity of potentiometer also gets increased. So, we can say that sensitivity of potentiometer is directly proportional to length of resistance. Again, if we reduce the driver voltage for a fixed length of potentiometer resistance, then voltage per unit length of resistance get decreased. Hence, sensitivity of potentiometer gets increased. So, it implies that sensitivity of potentiometer is inversely proportional to the voltage. Therefore, sensitivity of potentiometer is defined as the ratio of output voltage to strain. That is, S epsilon is equal to delta E by epsilon, where S epsilon is the sensitivity of potentiometer, delta is the output voltage and epsilon is the strain. When the term nonlinear resistance eta is very much less than 1, then sensitivity of potentiometer can be written as S epsilon is equal to R by 1 plus R the whole square into delta R1 by R1 minus delta R2 by R2 into V by epsilon, where small r is resistance ratio. In a case R1 resistance is replaced by the strain gauge resistance Rg and a fixed ballast resistor Rb is used in place of R2, and if the term Rb becomes 0, then the above equation becomes S epsilon is equal to R by 1 plus R the whole square into Sg into V, where Sg is the gauge factor and it is equal to delta Rg by Rg. This equation implies that the terms resistance ratio R and circuit voltage V controls or influence the circuit sensitivity. We all know V is equal to I into R. In this case, V is equal to Ig into Rg into 1 plus R. In terms of power, V is equal to root of Pg into Rg into 1 plus R, where Pg is the power dissipated by the gauge. Substituting the equation of voltage in sensitivity equation, we get S epsilon is equal to R by 1 plus R into Sg into root of Pg into Rg. These two independent terms, that is R by 1 plus R and Sg into root of Pg into Rg, influences the circuit sensitivity. Then next is sensitivity of Wheatstone bridge. We all studied Wheatstone bridge comprises of 4 resistors and a galvanometer. If a current passed through galvanometer is 0, it implies that the Wheatstone bridge is in balanced condition. If the Wheatstone bridge is not balanced, current flows through the galvanometer and causes deflection. The generated amount of deflection depends on the sensitivity of galvanometer, and it is expressed as S is equal to, that is sensitivity is equal to deflection divided by current. Galvanometer sensitivity can also be described as the amount of deflection per unit voltage across the galvanometer, and it is called voltage sensitivity of galvanometer, and it is conveyed as SB is equal to theta by E, where theta is the deflection and E is the voltage. Therefore, Wheatstone bridge sensitivity is defined as the ratio of deflection of galvanometer per unit fractional change in unknown resistance, and the equation is SB is equal to theta divided by delta R by R, where SB is the sensitivity of Wheatstone bridge, theta is the deflection, delta R by R is the change in unknown resistance. If all the resistance in Wheatstone bridge are equal or ratio of resistance is unity, Wheatstone bridge is more sensitive. If its sensitivity decreases when the resistance ratio becomes less than 1, and if the sensitivity reduces, eventually accuracy also decreases. Following are the two equations describes the strain sensitivity of Wheatstone bridge, that is S epsilon is equal to delta E by epsilon, which is equal to R by 1 plus R the whole square into delta R1 by R1 minus delta R2 by R2 plus delta R3 by R3 minus delta R4 by R4 into V by epsilon. As we all know, there are 3 cases of Wheatstone bridge: quarter bridge, half bridge and full bridge. And in each cases, resistance is replaced by strain gauge. If the 4 resistance is replaced by the strain gauges, it is called full bridge, and it has maximum sensitivity and therefore possesses higher accuracy. That's all about the sensitivity of potentiometer circuit and Wheatstone bridge. Thank you.